In this video, we are going to learn about the momentum. To understand the momentum, first we'll go through one small experiment, okay, so that you can understand the thing. So for the experiments, we've taken here one inclined plane. So this is called the inclined plane. See, in this plane, the one side of the plane is up, other side of the plane is down. So this type of plane is known as the inclined plane. And now we'll take one object here. This is one object I've taken here. Now we'll take two balls of different masses. So this is the bigger ball, this one is the bigger ball, and this one is the small ball here. Okay. So now what we're going to do, we are going to place the ball in this inclined plane at a certain height, and then we'll release the ball. So we'll check which ball is able to knock down this object, or when the ball will hit this object, whether this object will fall or not. Which ball can do that one? So first we'll go for the small ball. So let's start. Okay. So 1, 2, 3. Okay. So you can see that nothing has happened to that small ball. It's just only shaken little bit. Okay. Now we'll go for the next bigger ball, this one. So we'll just place the object here, then we'll just release it. So 1, 2, 3. So now see, this object has knocked down. Okay, it's fall down when the ball is hitting that object. So now the question is that when the small ball will hit the object, why the object is not falling down, and when the bigger ball is hitting the object, why the object is falling down? See, two balls are placed in the same height. That means when the ball will reach in this particular point, both the balls will get the almost same velocity. Okay, so now we'll release the ball. See, this will fall down, but when we'll take this ball here, release it, so nothing has happened to this ball. Okay, so you can see it. So what is the explanation behind this kind of things? So to understand this one, you have to know what is called the momentum. So momentum means, so first we write down the definition of the momentum so that you can understand. So write down the momentum, what is called momentum. So momentum of a body is the quantity of motion possessed by the body. Okay, so it is equal to the product of mass and velocity. Of the body. So this is the definition of momentum. Okay. Now momentum will be equal to mass into velocity. So mass means m, velocity is v, so mv, and momentum will be represented as p, small p. P is equal to m into v. So this is the momentum. Okay, so from the above experiment, definitely you can say this ball is having more momentum, so it is having the more mass, and the small ball is having less momentum because the small ball is having less mass. So now the question is, the momentum is a vector quantity. Let's write down this one. So momentum is vector. Momentum is a vector. So what is the SI unit of momentum? So what is the SI unit of mass? Kg. And what is the SI unit of velocity? Kg meter per second. Or I can write kg meter second to the power minus 1. Okay, so this is the momentum. So what you can say that, so when a small piece of stone is dropped, another example I want to say, suppose we take a piece of glass, a piece of mirror. So say mirror is here, take a mirror, okay, small piece of mirror. Now if I drop a small ball, okay, suppose this ball is made of you can say cotton, okay, when this ball will come and hit this this mirror, what will happen? Nothing will happen to this one, okay. But if the ball is like made of stone or made of iron or something, when this ball will hit this mirror of the same height, both the balls will be dropped from the same height, so what will happen? The mirror will crack into several pieces. So you can understand this one, that that heavy ball is dropped from a same height, the glass will breaks. So why? Because the heavy ball is having the more momentum than the than that cotton ball. Okay. So another example you can say that if I take a bullet here, small bullet. Okay, this is the bullet here. Now when this bullet is fired from a gun, so it is very difficult to stop the bullet. So when he will hit the object, what will happen? It will penetrate. It will penetrate through the object. But if I take the same bullet and if you throw by hand, then what will happen? It will not be able to penetrate this object. So you can understand, same bullet when is fired from the gun, it can penetrate. That means that time the bullet is having more momentum than the next case. So when the bullet was thrown by hand, the bullet will have the less momentum. Okay, so this is the concept of momentum. Now what you can say from here, if two objects of different mass are moving with the same speed, the effort need to stop the heavier object is more than the lighter object. So you can conclude from here. You can say, so write down, if two objects of different masses are moving with a same speed, the effort needed to stop the heavier object is more than that of for the lighter object. For the lighter, lighter object. Okay, so that is the thing we can conclude from here. Now another thing we can draw, suppose this is an object here. Okay, now we'll take this object. Now we just roll it down. See what will happen. So it takes some little bit another object here. So 1 second. Suppose you take this pin. So the small object will get stopped like this way. Now if I take the bigger ball here, now see, so it will cross, so it will cross, that object. Okay, so that is why it is very difficult to stop this bigger ball, rather than it is very easy to stop this small one. Okay. That is the concept of the momentum. Okay, now we'll go to some other explanation of the momentum. Another thing is that another explanation or another conclusion you can get from here, that is I'll draw the different color. So if two objects of the same mass are moving with different velocities, right? If two objects of same mass, you cannot see this one. Two objects of the same mass are moving with different velocities. The effort needed to stop the faster object is more than that the slower object. Okay, so what are the examples I've given for the bullet? It is like that. Now another example is or you can say another conclusion you can say for me, the effort needed to stop a moving object. We can write another thing, the effort needed to stop a moving object is directly proportional to its mass and its velocity. So these are the things about the momentum. Okay, another example also you can say, if someone is hit by a bicycle is coming with a very lower speed. Okay, so maybe the person will get injured, but if that same person, if is hit by the lorry or any kinds of like vehicles coming with the same velocity, will get like more damage will occur, because both the things are having same velocities but the masses are different. So you got to understand whatever I told you, the momentum will be different, so the effect in the two cases will be completely different. Now I'll do one small numericals based on this chapter. So the numerical I write down. So calculate the momentum of an object. Calculate the momentum of an object having mass of 500 gram moving with a velocity of 10 meter per second. So to find out the momentum of the object moving with it with 10 meter per second. So in this case, first solution, what you have to do, you have to find out, you have to convert all the units into the same unit. So this is gram. Gram is not the SI unit, but velocity is given in SI unit, that is 10 meter per second. So first you have to convert this gram into the SI unit. You can see this. Okay. So mass is equal to mass M is equal to 500 gram. So 500 divided by 1000 kg. Or you can say 0.5 kg. And then velocity is given here. V is equal to how much given? 10 meter per second. So momentum is equal to P is equal to M into V. So that means 0.5 into 10 meter per second, 0.5 kg, right? So we can get 5 kg meter per second. Okay, so this is written clearly. So 5 kg meter per second. This is the answer. Okay. So now today is up to this. So next class we will continue with the second law of motion. Okay. Thank you very much.